Hello, and welcome to a briefing about encrypted broadcast within a private community. Here's a statement of our problem. We have one sender, and we have a large number of receivers. The sender wants to post a message so that the receivers can see it, all of them. We could have one sender and any number, say a million, even millions of receivers. And while ECIES, we do have a public key for everybody, ECIS might be a solution. However, we'd have to do a message to each person or to each recipient, and that would require us to post each message many times, and we don't want that because we have to spend money. So we only want to post each message on the blockchain or in a public bulletin board once. So we want to post it so that only people in our network can decrypt it. Our solution cannot rely on some central storage key somewhere that could be hacked in a database or something. So this is not point-to-point, this is point-to-multi-point communication. And so as I said, we can't really do ECIES with key-to-key because that would just require too many messages. So what we need is some sort of common symmetric key that everybody can derive, but nobody has to store, and that should make it just slightly more difficult to steal. But before I discuss how we derive this common key, I want to introduce Shamir's secret sharing scheme. So Shamir is one of the three guys, RSA for Ravi, Shamir, and Adelman, who created RSA cryptography in 1977, I believe it was, and Adi Shamir created this secret sharing scheme in 1979. So there's a description on the Wikipedia page of how you can take a secret and you can divide it into a bunch of parts, and then you can recombine the secret using a subset of those parts. And there's a description of how it all works, and at the bottom it's all open source software. You can find it on the internet. I'm using this SSSS, the GNU GPL version. And I'll just do a quick demonstration of how it works. So we have a secret in mind, and we want to split it. And we're going to need two parts to reconstruct it, and we're going to split it into, I'm just picking the number 10. We're going to divide it into 10 shards. So it's asking for ASCII characters. I'm going to type some secret. So I just typed a sentence and then I hit enter, and the software has divided it into shards. In this case you can see 10 shards. Now to recombine them and form the secret, we can take any of these shards, combine, and now it wants 2 shards because remember we had a threshold of 2, so let's just pick a couple at random, and order doesn't matter. Let's pick 7 and 4 just because. And you can see it turned those 2 pieces of data back into the secret. So this is a way we can create a key. We can divide the key into multiple parts. We can distribute those parts randomly, and then anybody can recombine the parts to recreate the shared key and decrypt whatever they need to decrypt within the community. So going back to the presentation, this is just the same thing. So we are going to create some sort of key, and that'll have to be done in a key ceremony, kind of like how they created the private keys for Zcash Genesis block. And then we're going to use the scheme to divide the key into some number of shards. It doesn't have to be 10, and it doesn't have to be number of people in the community. If there's 10 shards, we're just going to distribute those 10 shards over and over and over again. Except for the last shard. We're going to keep that separate. We don't distribute that as people sign up. And how that looks over time is you get a number of people. Here I've got 5 different people with the app installed, and they have been given their own shard at random from that pool of shards, and that has been shared with them through ECIS, through private communication channels. So everybody in the community has their own shard assigned at random, and they have access to shard N which is assigned through some post-installation process. And so when somebody wants to be a sender, all they have to do is take their shard, in this case I just said shard X, it doesn't matter, and they combine their shard and the shard N that they were given after they signed up, and they can use that to recreate the key, and they encrypt the message with this key. And then on the receiving side, it's just the opposite. The receiver takes their own shard, and they take the common shard, they combine those, and they come up with the key. So let's look at some of the pros and cons of this approach. So the pros, we have a community-based encryption-decryption scheme that doesn't depend on a shared key being stored anywhere, although the shards are, but the key itself isn't installed or configured anywhere. And recreating the key can only be done with software. It can't just be put together by somebody who reverse assembles the application or something like that. And it's all open source and 100% free. Now on the con side, a secret is only as good as the number of people that know it. So if too many people know it, anybody can steal a phone in the network and therefore use the key if they know the PIN and hack the user, that kind of thing. And even if they don't, somebody in the community could talk or something, and that would, just repeat what they hear without. So we don't have perfect security. And as I already said, we have to have some kind of a sharding approach be done a priori, and they have to be allocated in a trusted manner. So there's a little bit of management that has to be done to keep the process reasonable. But that's it. It's a fairly simple approach. So I thank you very much and look forward to coming back in a future video. Have a good one.